We have one more section to cover in Chapter 3, that's Section 3.3. We will be taking a test at the end of the week. Yesterday, after your quiz, you guys received a study guide. When does that due?
Thursday.
It's due on Thursday. We'll review on Thursday, take our test on Friday. Section 3.3, today's section is on the graphing systems of inequalities. You should have all the notes that you're going to need for today. We have graphed linear inequalities. We did that last chapter. We're graphing systems of linear inequalities. If you think back to what we did, when you think back to what we did on linear inequalities, we graphed a line and then we shaded one side or the other, didn't we? When we have systems of inequalities, we're actually going to graph two lines. And we're going to do two shadings. Jerome, you need to pick up a note sheet, which is over here on the gray card, a ruler, and two markers. We're going to graph both of these inequalities and do two different colors of shading. So to graph the first inequality, we have a y-intercept of -3. So you have an x-axis, or y-axis will go down to -3. Put a dot. We have a slope of 2. That means we're going to go up 2 and over 1. And put a dot. Up 2 more, and over 1, dot, up 2 and over 1. And I like to extend this out so I've got a really good graph. I could have went down 2 and left 1 also. Now before you draw in your line, is this going to be a dashed or a solid line? Solid. The first one's solid because it is greater than or equal to. So take your ruler, draw in your solid line. When we graph an inequality like this, we do need to shade one side of the line or the other. How do we know which side to shade? You could look at the greater than or less than symbol. Normally we test a point just to be certain of which side we're going to shade. What point do we typically try to test? 0, 0. So let's do that. I'm going to put 0, 0, that point right there, into my first inequality. I'm going to put 0 in for x and y. So 0 is greater than or equal to 2 times 0. Minus 3. 2 times 0 is 0, and 0 minus 3 is -3. Is that true or false? That's true. So we would shade the side with 0, 0. That would be the top half of my graph. So take your marker, and if you would lightly shade on the top half of your graph. Again, I would take the lighter of the two markers and lightly shade. Don't shade real dark. For the second inequality, we have a y-intercept at 1, so we'll start by putting a dot at 1 on the y-axis. We have a slope of -1, down 1 and right 1, down 1 and right 1. Could have went up 1 and left 1. This time when I draw the line in, will it be a dashed or a solid line? It's going to be dashed, so we know that from the inequality. It is less than. So now we need to do shading on this line. So test in order of pair, we try to test 0, 0. So 0 in for x and y. The opposite of 0 is still 0, and 0 plus 1 is 1. Is 0 less than 1?
Yes.
That's true. So our line is, my line's a purple line. 0, 0 is true. So I want to shade, in this case, the bottom half. points intersect. These are systems of inequality, so I'm looking to see where those shadings overlap, where the shaded regions overlap, which in our case is right in here. Make sure it's really easy for me to tell which is your shaded overlapping region. If you want to use a third color, you can. Somehow just darken it, let me know, make it obvious if that is the region that is where your solutions are. So this is saying that any ordered pair in this region works for both of those inequalities. Any ordered pair in that region works for both inequalities. Look at the next one with me, please. The first inequality is already in slope-intercept form. We have a y-intercept of 1. We got it 1. We have a slope of negative 3/4. Down 1, 2, 3. Right 4. Down 3. And right 4. Could have went up 3 and left 4. For that first inequality, will we use a dashed or a solid line? Solid. We need to test an ordered pair to see which side to shade, so we'll test 0, 0. Testing the first inequality. Negative 3/4 times 0 is 0. And 0 plus 1 is 1. Is 0 greater than or equal to 1? That's false. But looking at my line, that means the side with 0, 0 is the false side. We shade the true side. So that would be the right or the top half of the graph. The second inequality is also in slope-intercept form. We have a y-intercept of negative 2. It looks like we also have a slope of negative 3/4. So we're going to go down 3 and right 4. Down 3 and right 4. Could have went up 3 and left 4. We'll use a dashed or a solid line for the second inequality. Solid. We again need to test an ordered pair. I always try to test 0, 0 if I can. When can we not test 0, 0? When the line goes through, you'll have to pick something else, another ordered pair. So we have 0 is less than or equal to negative 3/4 times 0 minus 2. Negative 3/4 times 0 is 0, and 0 minus 2 is negative 2. Is 0 less than or equal to negative 2? It's false. So again, the side with 0, 0, which would be the top half here, is the false side. We need to shade the true side, so we will shade the bottom half. So our solutions are where the shadings overlap, the shaded regions overlap, but they don't overlap. So where are our solutions? There aren't any solutions. We don't have an area or a region where we have the same solution, so we would not have solutions. Skip the next problem on your notes. You guys really should be okay with this. We covered this in Algebra 1. The next example, though, you'll notice it has 3 different inequalities. I want to change a couple of these inequalities. I want to put them out to be a nicer answer than it is. So if you would, change the first and second inequalities. to change it here. Yes, I have. These are the correct ones. If you would please change the ones on your paper to the ones that I've got up here. I have already changed them on my slides. But the handout is incorrect. Change the first and second inequalities. That's 15, y is greater than or equal to 15 fourths x minus 8, and y is less than 7. The directions tell us to find the coordinates of the vertices of the triangle formed by these three inequalities. So they're telling you it's going to form a triangle, and they want you to find the vertices. What are vertices? Think about what a triangle looks like. Yeah, where your lines intersect. Those corner points. Those are called our vertices. We're trying to figure those out. So, let's graph each of these inequalities. The first inequality has a y-intercept of -8. So I'm going to go down to -8 on my y-axis. I have a slope of 15, 4. So that means I'm going to go up 15 and over 4. I can't go up 15 and over 4 more because it's going to be off my graph. So in this situation, 2 points is going to be sufficient. Well, we use a dashed or solid line to draw on this solid line. Now, they're asking us to find the coordinates of the vertices of the triangles. So I want to know those endpoints. Does it really matter which side I shade? You're going to form a triangle with these 3 lines. You're just wanting the vertices, so I'm not so worried about the shading here. You could shade, which would be the left side, but there's no reason to shade. We're just looking for the coordinates, the vertices. For the second inequality, we have y is less than 7. Think about what that's going to look like. It's going to be a horizontal line at what value? 7. 7. This time we will have a dashed line. So do I know one of my coordinates and my vertices already? I do. What is this point right here? We can go ahead and list it. 4, 7. When we draw on our third piece, we should be able to find the other 2 vertices. Now, this third inequality is not in slope-intercept form, but is this something we could easily put into slope-intercept form? Of course. Just divide by 4. So we should have y is greater than or equal to -15 fourths x minus 8. So we have a y-intercept of -8. We should be familiar because we already have a y-intercept of -8, don't we? We have a slope of -15 fourths, so I don't want to go down 15 and over 4. That's not going to give me another vertice. What's the better option? Go up 15 and left 4. Which of course puts me in a point on that other line. Again, they're wanting the coordinates of the vertices. So we've got a point down here on the y-axis at 0, -8. And we have a third point over here at the -4, 7. I'm asking for the vertices of those triangles. That's what it is. Those 3 points. at the next example with me, please. This will probably be our last one. Louis has 2 jobs and can work no more than 25 total hours per week. He wants to earn at least $150 per week. Graph the inequalities to show the possible combinations of hours worked at each job that will help him reach his goal. So we want to come up with a system of inequalities here. There's a couple of things we don't know. What do we not know? How many hours? We know a total number of hours, correct? Total 25 hours, but more specific, Cassandra. How many hours in each job? Okay, we know a total of 25 total hours. We don't know how many in each job. So I'm going to let X be the number of hours as a busboy. And Y is going to be the number of hours as a clerk. We know that he wants to work no more than 25 total hours. Some of those hours as a busboy, some of those hours as a clerk. How can we write an inequality there? Alex.
X plus y is less than
You got it. X plus Y is less than or equal to 25. The number of hours as a busboy, X, plus the number of hours as a clerk, Y, has to be less than or equal to 25. He wants to work no more than 25 hours. We know that Louis wants to make $150. He wants to make at least $150. How much is he being paid per hour as a busboy? $6.50. So that would be $6.50 per hour, so 650x. Plus, he's being paid how much as a clerk? $8 per hour, so 8y. He wants to make at least $150. Greater than or equal to 150. At least. So they want us to graph this inequality. Guys, when you're graphing, you've got lots of tools. You could make an XYT chart. You could use the cover method. You could put it in slope-intercept form. I really don't care what method you use. For these, I'm thinking we may have a decimal here. We've got 650. It might come out to be a nice number. But we may want to use our intercepts. I think it'll be easiest to graph. It'll likely be easy to graph that way. So, like for this first inequality, if I use my intercepts, what's my x-intercept going to be? 25. So now we need to decide what we want to go by. I think 5 would be okay. I'm going to spread this out a little bit. I've made every other box 5 units, so I guess I'm going by 2.5s. Make sure you do label x-axis is the number of hours as a busboy. Y-intercept of 25. Excuse me, an x-intercept of 25. What is our y-intercept? It's also 25. Make sure you label your x and y axis so we know exactly what they are referencing. So an x-intercept of 25 and a y-intercept of 25. Okay, we could draw the line in there. Is that going to be a dash or a solid line? Solid. I'm just worried about that first quadrant because it's not going to make sense to have negative number of hours, is it? Negative amount of money. So it doesn't worry. I'm not worried about any other quadrant other than the first. For this second inequality, let's find our x and y intercepts. You find the x-intercept, cover up your y. So we have 650x equals 150, divide by 650. So about 23. So our x-intercept is 23. Hang on, before we get any further, let's do some shading here. We didn't do that on the last one, we should have. Which side are we going to shade? X plus y is less than or equal to 25. Put 0, 0 in there. Is 0 less than or equal to 25? So shade the side with 0, 0. Before we go any further, go ahead and shade that first inequality. Shade the bottom half, side with 0, 0. Go back to that second inequality. We did have a y-intercept of approximately 23. Right there. And for a y-intercept, we would have 8y is greater than or equal to 150. So take 150 divided by 8. It's about 18.75. If you test 0, 0 in there, we're going to have 0 plus 0 is 0. Is 0 greater than or equal to 150? That's false. So this time we would shade the top half of our line, which includes that little piece there on the inside. Okay, so the problem asks us to graph the inequalities to show the possible combination of hours worked at each job that will help him reach his goal. Well, where would that information be located? In that overlapping region right in here. So I'm going to shade it in a different color so it's easier to see. So any combination of hours worked at each job that falls in my pink region is going to satisfy his needs of making $150 and working no more than 25 hours. So can you give me some combinations of hours that he could work at each job? What? 5, 20. Yep, that would work. 5, 20. So that means 5 hours as a busboy, 20 hours as a clerk. What else? Another ordered pair of a combination of hours worked at each job. 10, 15. Those numbers. So 10 as that'll work. 10, 15. Let me ask you, what if he worked 21 hours as a clerk? Would that give him enough? 21 hours as a clerk. 0 hours as a busboy. 0 hours as a busboy, 21 hours as a clerk. That would be about right here. Is that in that shaded region? Mm-hmm. What if you worked 5 hours at each job? Is that going to give him enough? That would be here. Is that in the pink shaded region? It's got to work for both. It would satisfy his need to work less than 25 hours, but it doesn't give him that prime condition there where we want the $150. My third ordered pair would be 0, 21. And you can come up with lots of different ordered pairs or combinations of hours worked for Louis. Alright, I'm going to stop here and let you guys spend some time working. Just a reminder that that study guide is due when? Thursday. Study guide's due Thursday. And test on Friday. class on Friday. We'll review on Thursday also.